Now let's talk exponents. As a reminder, this bigger number, that's like the normal size of a number, that's called our base. And the thing that's at the top right-hand corner of it, that we're raising it to the power of, that is called our exponent. So we've got a base and an exponent. Now we have some rules with exponents when they are integers. If we have two bases that are the same, that are being multiplied, whatever their exponents are, we're going to add them. That's called the product of powers. So if we look at this first example, we have an x and an x. Those are both our bases. The exponents are 5 and 3. Since we're multiplying the bases, we're going to add the exponents. 5 plus 3 is 8, so this is x to the 8, x to the 8th power. If we're dividing our bases, we have this thing called the quotient of powers, where instead of adding like we did when we were multiplying the bases, when we're dividing the bases, we're going to subtract the exponents. So, in this example, x to the 5 over x to the 3rd, they both have bases of x, so we're going to look at their exponents and subtract them. 5 minus 3 is 2, so this is simplified to x to the power of 2, or x squared. If we have something to an exponent to another exponent, right, there are multiple powers in this same base, then we're going to multiply their exponents together. So here we have x to the 5th raised to the power of 3. So we're going to multiply 5 and 3, and that leaves us with x to the 15. The same idea works if whatever's on the inside of your parentheses is being divided. Even if they have different bases, we're still going to raise each thing that has an exponent to this outside exponent. So a to the m over b to the n, all of that is raised to the power of p. If we multiply each exponent by p, we have a to the mp over b to the np. So in this example, x to the 5th over y to the 4th, all of that is raised to the power of 2. We're going to multiply both exponents by this outside exponent of 2. So it leaves us with x to the 10 over y to the 8. If we have a negative exponent, we can rewrite that as a fraction, 1 over, and then we're going to keep our same base but switch the sign of the exponent. So we start with a to the negative n, that becomes 1 over a to the n. If you already have it in a fraction and you want to take that negative exponent out of a denominator, we would just change 1 over a to the negative n to be a to the n. So in this example, 5 to the negative 3 can be rewritten as 1 over 5 to the positive 3. Finally, anytime you have something raised to the 0, that is equal to 1.